Hello everyone. In today's lesson we're going to look at rounding significant figures when performing operations including addition and subtraction and multiplication and division. So we're going to get started today with looking at addition and subtraction and how we can round to the correct number of significant figures when performing these operations on measurements. So let's start with a simple example. Let's say we're trying to add two length measurements. We have 23.1 centimeters and we have 20.105 centimeters. So first, let's take a look at the number of significant figures in each of these measurements. 23.1, these are all non-zero digits, so all three digits would be significant. So we have three sig figs here. And then in 20.105, we have three non-zero digits and two zeros, but both of the zeros are in between non-zero digits. So both of those zeros would be significant, and we have five significant figures in that measurement. Now, turns out that when we're adding and subtracting, we actually don't look at the total number of significant figures in the measurements in order to determine how to round the final answer. Instead, when we're looking at adding numbers, such as we have in this case, or subtracting numbers, what we're going to look at is the fewest number of decimal places, or the fewest number of digits after the decimal in our original measurements. So the answer, when we are adding or subtracting numbers and rounding to the appropriate number of significant figures, must have the same number of digits after the decimal place. As the original measurement that is least precise. So that is to say the original value that has the fewest digits after the decimal place. So if we look at our measurements here, we've got 23.1 with one digit after the decimal place, and then we have 20.105 with three digits after the decimal place. So according to this rule, the original value that's going to limit the number of significant figures in our answer is going to be 23.1. Since it has fewer numbers or digits after the decimal point, this is going to limit the number of digits after the decimal point in our answer. So let's go ahead and add these two numbers together. Punch into our calculator, we get 43.205 centimeters. But again, this is not rounded to the appropriate number of significant figures. Our final answer has to have the same number of digits after the decimal as the least precise original value. And the least precise original value is 23.1 with one digit after the decimal point. So I'm going to have to round 43.205 centimeters to the nearest tenth. So let's give ourselves a little bit of space here, and we will go ahead and do our rounding. So I go ahead and I find that final significant figure, which in this case is going to be the 2. It's the first digit after the decimal. That's the one I have to round to match the level of precision of my least precise measurement. To determine whether I keep that as a 2 or I round it up to a 3, I have to look at the next number. So I've got a 0 because that's less than 5. We're going to keep this as a 2. We're going to round our answer to 43.2 centimeters. So there are varying schools of thought on how to round up or down based on the next digit or sometimes the next two digits. We're going to keep it really simple in this class. If the next digit after the last significant digit is less than 5, you're going to keep that last significant digit the same. If that next digit is greater than or equal to 5, then we're going to increase that last significant digit by 1. So in this case, because it's 0, less than 5, we keep 43.2 centimeters and round to sig figs. Now, it is the case here that we have the same number of sig figs, 3 total sig figs, as we did in the original measurement with the least number of sig figs, but that's coincidence in this case. Remember, the key with addition and subtraction is the number of digits after the decimal point. We have to round our answer to the number of digits after the decimal that is equal to the original value with the fewest number of digits after the decimal. So be careful with that. And the same rule applies to subtraction as what we've just demonstrated here for addition. So next, we're going to take a look at multiplication and division. And similar to what we saw with scientific notation, it's actually a little bit easier to round to the appropriate number of significant figures when performing multiplication and division than it is with addition and subtraction. So again, let's start out with an example here. Let's say we have 115 grams, and we're calculating a density. So that 115 grams corresponds to a volume of 30 cubic centimeters. So let's say D equals mass divided by volume. We're calculating a density in this case. So again, let's start out by looking at the number of sig figs in each measurement. 115, those are all non-zero digits, so I've got 3 sig figs. Now 30, we've got one non-zero digit, and then we have a trailing 0, but there's no decimal point here, so that trailing 0 is not significant in this case. 30 cubic centimeters only has one significant figure. So what is the rule for rounding when performing multiplication or division to the appropriate number of significant figures? Well, it turns out that your answer in the case of multiplication or division must have the same number of sig figs as the original value with the least number of sig figs. So that is our rule for rounding to sig figs with multiplication and division. So what we do, we go ahead and divide through 115 grams divided by 30 centimeters. That's going to get us 3.833 grams per cubic centimeter. Now this is the unrounded value. I have to look at my original values in the calculation, and I have to round my final answer to the number of significant figures that matches the lowest number of sig figs of the original values. So 115 has 3, 30 cubic centimeters has 1. 1 sig fig is the lowest number of sig figs of the two original values. Therefore, I have to round my final calculated answer to 1 sig fig. So let's give ourselves a little bit of space. Once again, to do the rounding, we're only going to have one significant digit, significant figure in our final answer, and it's going to be this first digit. So we look at the digit immediately following that last significant figure, the only significant figure in this particular case, and it's an 8. So that means that we're going to round the 3 up to 4. And 4 grams per cubic centimeter is my final answer. So that's how you round to the appropriate number of significant figures with multiplication and division. We did an example of division, but the process would be the same for multiplication.